So in an earlier video, we showed that the integral of secant is natural log of secant plus tangent. And we used mainly u substitution with some algebra to do it. So in this video, we're going to evaluate this integral by a different method. We're going to use u substitution and partial fraction decomposition so we're going to use u sub and partial fraction decomposition to obtain the same result. So let's take a look at how this is done. So we take our integral, the integral of secant, and first thing we do is rewrite secant as, in terms of cosine, 1 over cosine of x. Next, we use some basic algebra. We multiply 1 over cosine by form of 1, which is cosine over cosine. This doesn't change anything. It's still the same integral, but now we view it as, in the numerator, cosine of x, and in the denominator, cosine squared of x. It's the same thing as secant. Next, we realize that cosine squared x is equal to 1 minus sine squared x. So we rewrite that. And we now are going to factor the denominator as 1 minus sine x times 1 plus sine x. And this is still equivalent, the same thing as the integral of secant. So next we want to do u substitution. U will be sine, which means that du is cosine of x dx. And let's rewrite that integral. Cosine x dx is now just du, or 1 du. And in the denominator, we have 1 minus u times 1 plus u. And then to evaluate this integral, this is where we're going to use partial fraction decomposition. We're going to take 1 divided by 1 minus u times 1 plus u and write it as a over 1 minus u plus b over 1 plus u. Then we're going to multiply both sides by the denominator on the left, which is 1 minus u times 1 plus u. And then that will give us 1 on the left side, and then a times 1 plus u, because 1 minus u is canceled, plus b times 1 minus u, because 1 plus u is canceled. Let's plug in u equals minus 1 into both sides. On the left, we still have 1. On the right, that just gives us 2b, which means b is 1/2. Let's now plug in u equal to 1, and that gives us 1 equals to 2a. That means a is 1/2. And our integral of 1 divided by 1 minus u times 1 plus u du now can be expressed as 1/2 times the integral of 1 divided by 1 minus u du plus 1/2 times the integral of 1 divided by 1 plus u du. Now, let's look at that integral on the left, and let's just rewrite it by multiplying it by minus 1 over minus 1. We want to view it in this form. The numerator, or we'll have the numerator minus 1 will give us minus 1/2. The denominator minus 1 will go into the denominator and turn 1 minus u into u minus 1. And we leave the other one alone. 1/2 times the integral of 1 over u plus 1. Well, these are basic integrals, so that the left integral is minus 1/2 times natural log of absolute value u minus 1 plus 1/2 times the natural log of absolute value of u plus 1. And combining these two into a single log, it's 1/2 ln of u plus 1, absolute value of un plus 1 over u minus 1. Now let's go back and replace u with sine x. So it's 1/2 ln absolute value sine x plus 1 over sine x minus 1. It doesn't look like the answer. We know it's ln of secant plus tangent, so we want to make sure that that's equal to ln of secant plus tangent. So we're going to take sine x plus 1 over sine x minus 1 and sort of multiply it by the conjugate of the denominator in the form of 1, which is sine x plus 1 divided by sine x plus 1. All inside absolute value. It's just a form of 1, nothing changes. That becomes 1/2 natural log absolute value sine squared x plus 2 sine x plus 1 in the numerator over sine squared x minus 1. The middle terms cancel in the denominator. Sine squared x minus 1, that's in the denominator, can now be written as negative cosine squared x. And let's rewrite this as 1/2, pull the negative in front, ln of negative, and then we have in the numerator sine squared x plus 2 sine x plus 1 over cosine squared x. Now, absolute value will absorb that negative in front, and we can just remove it, so it's 1/2 ln absolute value of sine squared x plus 2 sine x plus 1 divided by cosine squared x. And now let's simplify this. This is 1/2 ln of absolute value of, we divide every term by cosine squared, so it's sine squared x over cosine squared x plus 2 sine x divided by cosine squared x plus 1 divided by cosine squared x. And let's take a look at that middle term. So that is 2 sine x divided by cosine squared, which we can write as cosine x times 1 over cosine x. Sine x over cosine x is tangent, 1 over cosine is secant. And our answer now can be written as follows: 1/2 times natural log absolute value sine square over cosine squared is tangent squared x plus 2 tangent x times secant x, and 1 over cosine squared is secant squared x. We notice that that is a perfect square, so that we can write that as ln of absolute value of secant x, tangent x plus secant x quantity squared. That's the same thing as what you see in the line above. And now we can rewrite this as ln of absolute value of tangent x plus secant x squared, and then the 1/2 in front will come up to the exponent and multiply that 2. 2 times 1/2 is 1, and of course we end up with the same answer as we did before, ln of absolute value of secant x plus tangent x, and we can add a constant here. So to summarize, you saw here a different way to evaluate the integral of secant x. It still equals to natural log of absolute value of secant plus tangent plus constant c, and we did this using partial fraction decomposition plus some u substitution.